Hello everyone, today we'll get to know how to do series of future value of ordinary annuity. So on your screen you see the question. Suppose you deposit $2,500 at the end of year 1, nothing at the end of year 2, $750 at the end of year 3, and $1,300 at the end of year 4. Assuming that these amounts will be compounded at an annual rate of 15%, how much will have to deposit at the end of 4 years? So to do such math, the first thing you need to do is drawing a graph. Then it will be way more easier for you to do the math. So how many years? 4 years, right? You see on your screen, it's a math of 4 years. So how much you deposit at the first year? 2,500, right? In the second year, you deposit nothing, that means 0. In the third year is $750, and in the fourth year $1,300. So the formula of this series is P means payment into 1 plus I to the power n minus 1 plus P into 1 plus I to the power n minus 2. So each year you deduct the power, okay, you deduct the n and it will be increased by 1. So in the first year you deduct n minus 1, in the second year you deduct n minus 2, in the third year you deduct n minus 3. Okay, so n is the number of years. Here the n is 4. So according to the formula, let's do the math. The first year's payment is 2,500. So from this graph, look at this graph, don't need to look at the question right now. So from this graph we can do the math according to the formula. So you see 2,500 is the first deposit amount multiplied by 1 plus I, or you can say 1 plus R. Both refers to the interest rate. So the here interest rate is 15%. So 1 plus 0.15 to the power n is 4 years, that's why n is 4, minus 1 plus 0. So nothing deposited in the second year, okay, is 0. So in the third year is 750 into 1 plus I, which is 15% to the power n minus 3. Now don't get confused, because in the first year is n minus 1. If it was something in the second year, for example $100 for say, then it would be 100 multiplied by 1 plus I, which is 15% to the power n minus 2. But as nothing is deposited in year 2, that's why we're not doing this. We're not doing anything here, we're not calculating, we're just keeping it 0. Okay, but n minus 2 is gone here. So in the third year you have to deduct 3 from n. So 750 deposited in year 3 multiplied by 1 plus 0.15 to the power n minus 3, so 4 minus 3, plus 1,300 deposited in year 4 multiplied by 1 plus I, which is 15% to the power here 4 minus 4. You see it has increased, by 1 every year. First year n minus 1, second year it would be n minus 2, but as nothing deposited, that's why we are keeping it 0. In the third year n minus 3, in the fourth year n minus 4, so 4 minus 4. So if we calculate it, we get in the first year 3,802.19, in the second year is 0 because nothing deposited, in the third year is 862.5, and in the fourth year is 1,300 because the power is 4 minus 4 is equal to 0. Okay, so it will be like only 1300 in the last year. So the total amount would be $5,964.69. So when these amounts will be deposited, you will have $5,964.69 at the end of 4 years. Okay, so that's it.